A pay TV service sends a signal through the telephone lines to each of its customers every hour. The length of the signal is between 2 and 9 seconds and follows a uniform distribution. So it might be handy just to graph that over here. So it goes from 2 to 9, and we know it's a uniform distribution, so that's the rectangular distribution, so it's just flat across here. And this gap is 7, and we know the area of this rectangle has to be 1, so that needs to be 1/7. So define the probability density function for the length of the signal. We can say now that f of x is 1/7 when x is between 2 and 9 and 0 otherwise. Determine the probability that the signal is longer than 4 seconds. So that's just going to be the area from 4 up to 9. So the width is 5, the height is 1/7. So that's just going to be 5 times 1/7, which is 5/7. Determine the probability that, on any given day, at least half of the signals are greater than 4 seconds. Now they're sending one an hour, so that means we have 24 signals in a day. The probability of being longer than 4 seconds is 57, and we should be able to see that this is a binomial distribution. 24 trials, probability of success 5/7. At least half the signals is the probability that x is greater than or equal to 12. So we're going to be using a binomial distribution. So that's a binomial CDF. And we're going from 12 up to the number of trials, which is 24. Number of trials is 24. And the probability of success is 5/7. So that gives us 0.993. One particular day, fewer than 21 signals, now remember this is a discrete distribution now with this binomial, so that's going to be less than or equal to 20, were longer than 4 seconds. Determine the probability that at least 15 were longer than 4 seconds. So what we're being asked for here is the probability that x is greater than or equal to 15, given that x is less than or equal to 20. So that's the probability of x being between 15 and 20 divided by the probability that x is less than or equal to 20. So we just need to calculate that. So 15 and 20, we could just edit this one. So you go 15 and 20. 24 5/7. So that will be that. And then we also want just the less than or equal to 20. So once again we're going for a binomial CDF. And less than or equal to 20, so the lowest it could be is 0. And then we're going for 20. And the number of trials is 24. And the probability is 5/7. So that's that. So our answer is going to be this one here divided by this one here. And that gives me 0.875.